Hello, in this video we're going to look at Module 6 more problems. So I suggest try these problems on your own first, then watch this video to review your work. Okay, so please try this problem before you start watching this video. Okay, because it's very important for you to actively try these problems to identify what you know and you do not know. Okay, so let me go over the first one. It's arctangent. Remember, arctangent is same thing as tangent inverse. So these two are the same meaning. So this is asking what angle between negative pi over 2 and positive pi over 2 would give tangent of that angle such that negative 1. And here's only one angle. For inverse trig functions, this should give us only one angle. Because inverse trig is a function, because arctangent is a function though, one input should only give us one output. Okay. So from the unit circle, we only look at right half of the unit circle, but this is negative angle. So these are considered negative angles. And these are positive angles up to positive pi over 2. Okay. So tangent is sine over cosine, and slope is 1 at this angle right here, pi over 4. Because both sine and cosine are the same value, so sine of pi over 4 is square root over 2, and cosine of pi over 4 is also square root over 2. Therefore, this angle will give us tangent of this angle. Tangent of this angle will give us negative 1. So this answer is pi over 4. Okay. Again, part of knowing inverse trig function is that this gives only one answer. Okay. Second one, sine inverse of negative half. This is asking what angle between negative pi and the positive 2 will give us sine of that angle, negative half. Okay. So let me write it shortly. Sine, what angle will give us sine the negative half? But again, this angle must be between negative pi over 2 and positive pi over 2. So for sine and cosine, we look at the same range of angles. For cosine, sorry, I said tangent. I meant to say tangent. So for sine and tangent, so for sine inverse and for tangent inverse, we look at negative pi over to positive pi over 2. For cosine inverse, we look at 0 to pi. So know the distinction, as I talked about in the main concept module 6 video. So here, what is an angle? So again, we refer to the unit circle. Then we'll see that it's this angle right here. But again, we cannot just use the unit circle angle value. We have to, you get the negative. So in unit circle, this is 11 pi over 6, but we have to write it as a negative angle. So this is negative. This answer is negative pi over 6, the answer. Because it must be between this range. Okay. So let's look at the next problem. Next one says multiply and simplify. So this is just a practice of multiplying and manipulating trig expressions. So we'll multiply this both sides. Sorry, not both sides, for both of them, like distributing. Right? So then what we get is sine x times cosine x times cotangent x plus sine x times cosine x times secant x. Then we can rewrite cotangent as cosine over sine. Plus sine x times cosine x. Secant is 1 over cosine. Then we can simplify this sine and sine right here. Cosine and cosine. So we simplify this to cosine times cosine right here gives us cosine square. Cosine square x plus sine x. Okay. So we multiply these and simplify by rewriting some of the trig expressions in terms of sine and cosine. Okay. So let's look at number 3. It says complete the identity. Okay. So again, this is just another way of saying simplify this trig expression. Okay. So for these type of problem, we have to remember some of the identities, and some of those identities, one of those identities is Pythagorean identity, and one of them using cosecant square is cotangent square x plus 1 equals cosecant square x. So this is one of those that you have to know. It will not be given in the formula sheet, or it will not be given within the quiz. So you have to know this. Not only you have to know this, you have to know when to use this. So how do we know to use this? Because we see cosine square beta here. So instead of cosine square beta, we can write it as cotangent square beta plus 1. And again, this b looking thing is called beta. It's just another variable name. So we can treat that just like an x. So cosecant square beta, we can write it as cotangent square beta plus 1 over cotangent beta. Then we'll see that this negative 1, positive 1 cancels out. Then we have cotangent square beta over cotangent beta. And this we just have cotangent beta. So we're able to simplify this expression to this right here. Okay. Again, I want to emphasize, try these problems on your own first, then watch the video or watch each problem to review your work. Okay. So let's look at number 4. Again, in this section, module 6, it's very important to identify what kind of problem you're dealing with. So here it says evaluate, right? That means we want to find exact value of sine 15 degree. But sine 15 degrees not on the unit circle. So we have to use one of the trig identity. So in this case, we have to use sum and difference identity. So first we have to find two angles that are on the unit circle. That if I either add or subtract those two angles from unit circle, I can obtain 15 degrees. So here if I subtract, for example, 60 and 45, we can get 15 degrees. So here we have to use a sum and difference. Again, these formulas will be provided. You do not have to memorize these. So sine alpha minus sine beta is sine alpha times cosine beta minus cosine alpha times sine beta. Okay. So here we treat this as alpha, this as beta. So let's try that. So we're going to use this formula. So sine 60, well, let me write this. Sine 60 times cosine beta right here, cosine beta. Beta is 45, so 45 degree. Minus cosine 60 degree times sine 45 degree. Okay. Okay, so then we can find each of these values from the unit circle. Right. So this one is square 3 over 2 from the unit circle, square 2 over 2, minus 1 over 2, minus square 2 over 2. So we simplify square 6 over 4, minus square 2 over 4. It gives us square 6 over 2 minus square 2 over 4. So this is our final answer. Again, how do we know to use sum and difference formula? First, we have to look at the problem. It says evaluate, and this angle 15 degrees not on the unit circle. That means we have to do something else to evaluate this value. Okay. And we can obtain 15 degrees by subtracting two angles from the unit circle, 60 and 45. And you could have chosen other degrees as well. You could have chosen 150 degree and 135 degree, right? But as long as you use the correct unit circle values, you get the same answers. So let's look at number 5. Number 5 says solve, right? Again, this is another type of problem. Solve the equation on this interval. Okay. So that means I want to find the unknown variable's value. So here x is unknown. So I want to find x values. Okay. So first, this is cosine 3x. So first we want to find angles on unit circle. That gives us cosine of that angle will be negative half. What are those angles? Again, refer to unit circle, and we'll get two angles on your circle. We get 2 pi over 3, and we get 4 pi over 3. So this angle must be 2 pi over 3 and 4 pi over 3. But that angle here is actually 3x, right? So we set it to 3x to solve for x. Multiply 3 both sides. We get x equals 2 pi over 9. We get x equals 4 pi over 9. Then we have to check if each of this angle is in this range right here. This range. Okay. And they are. So those two are the final answer for this problem. So final answer is 2 pi over 9 and 4 pi over 9. Oops, 4 pi over 9. Okay. But let's hypothetically, let's say this was not given. But problem says just solve the equation. If it only said that, then to these two answers, we have to add infinite number of circles. So if this range is not restricted, we have to add 2 pi k to each of these answers. Because we can add full circle or subtract full circle to find a coterminal angles. Right? So if this restriction is not given, then we have infinite number of answers. And these two gives us infinite number of answers. Because we can keep adding a full circle or subtracting a full rotation of circle to find the coterminal angles. Okay. So something to keep in mind. So we do have to pay attention to this interval. Okay. So now the questions of solving. Again, solving the equation. Right? Because we're finding for unknown variable. So here, before I write it, here we cannot put only cosine into only one side. So usually if we can, we want to have all the trig expression on one side and all the numbers in the other side. But we cannot do that here. We did it, but we have two cosines in the left side, right? But still, this doesn't help us. So here, what we have to do is we have to actually set this equal to 0 first. Plus 1, I'm going to add 1 both sides to 0. Then what I'm going to do is I'm going to treat a, or cosine, as entire variable a. Then I'll rewrite it using a. Then I get 2a squared minus 3a plus 1 equals 0. The reason I do this is so that we can factor this, if we can factor them. Okay. So see if we can factor them. So we have 2a and a equals 0. So if we do minus 1, negative a, negative 2, yeah. So we can factor this expression, this equation, to 2a minus 1 times a minus 1. So that means that either this has to equal to 0 or this has to equal to 0. So let me write that in the more room here. So either 2a minus 1 has to equal to 0 or a minus 1 has to equal to 0. But a is cosine. But actually we can solve for a first. A has to be half. Here a has to be 1. But a is cosine. So then now we can set it up using trig. Again, cosine half and cosine x equals 1. Now from here, now we solve. Solve as in find the angle from the unit circle. They will give us half. Again, it's restricted, 0 and 2 pi. So we have to only look at those values from the unit circle. Otherwise, again, we have to add 2 pi k to each of the answer we find. So here from the unit circle, we get pi over 3, 5 pi over 3. And for cosine, for cosine to be 1, it has to be 0 radian. So these three are the answer for this problem. Okay, so let's look at number 7. Given sine theta 4 over 5, and theta is in the second quadrant. Find sine 2 theta. Again, this also should indicate to you that we have to use some kind of identity. Okay, so I'm going to write this. Don't write this. Sine 2 theta is not equal to 2 sine theta. They're not same thing. Okay, so don't assume that. So you have to identify first that we know that sine 2 theta equals 2 times sine theta times cosine theta. So that means in order to evaluate this, I need to find what sine theta is, which is given in the problem. But now I need to find what cosine theta is. So now we need to draw a triangle. Okay. Theta is in the second quadrant. This is not a perfect right triangle. Well, perfect as I can draw it. Here's a right triangle. Here's the theta. Sine is 4 over 5. That means this length is 5. Hypotenuse or radius length is 5. And this vertical length is 4. And we can find this length using Pythagorean theorem. 5 squared equals 4 squared plus, let's call it x squared. X. Okay. And if we solve for it, we get x equals 3. Very important thing, because when we're looking at quadrant, okay, here x value is negative, so we must write negative 3. Okay, think of unit circle. If you think of unit circle, right, the angle quadrant cosine value is negative. Same here as well. So it must be negative 3. So this tells us that cosine theta is actually negative 3 over 5. So if you want to solve for sine 2 theta, well, we want to find sine 2 theta, we'll get 2 times sine theta 4 over 5 times negative 3 over 5. And multiply, we get negative 24 over 25. This is the final answer. Again, it says find 2 theta. Okay. So here, what should it indicate us that what kind of problem this is? It's the fact that we have 2 theta here. Right? And it gives us different kind of information. Second quadrant, and it gives us what sine theta is. So here, whereas this one, yeah, we still have, through cosine 3x. Right? But it has to solve the equation, right? Solve the equation on this given interval. Right? So there's difference. Solving the equations and finding what entire cosine is different. So this one's finding entire what cosine 2 theta is, whereas number 5 was solving for the x, okay, the angle. Here we still know what angle is. We still don't know exactly what it is. All we care about is finding sine 2 theta, which is this. Okay. Let's go number 8. Now, it says verify that 1 plus tangent x plus tangent x equals 1 over sine x over cosine x. So remember, general rule for verifying expressions is that we want to start with more complicated side. Okay, so now here, how can we determine more complicated side? Maybe you could argue that both looks more complicated. If that's the case, then we look at which one has more term. This has 2 separate terms, whereas this has 1 term, right? Only one fraction. Here, we have a fraction plus another thing. So the fact that we're adding 2 things indicate that this is more of a complicated side. Okay, so we're going to begin from here, and we're going to simplify to make it look like the right side. And that's what the verifying means, right? So we're not solving for anything here. We're just verifying through the work that left and right are equal. Okay. Okay, so let me write 1 plus tangent x plus tangent x. So first, again, sometimes, for these problems, it takes trial and error, right? So keep that in mind. You might not be able to get it right away. That means you have to try some other ways. So here, I'm going to write tangent as sine over cosine for both of them first. So then this is reciprocal. So this is the same as cosine over sine plus sine over cosine. Now we need to combine these 2 fractions, right? In order to do that, we need to have a common denominator. Okay. So you need to have a common denominator. Here, for this one, I'm going to multiply sine over sine, sine x over sine x. Here, I'm going to multiply cosine x over cosine x. So I'm kind of messing me right in the bottom. So if I multiply cosine over cosine, I get cosine square x. And for the second one, I get sine square x. And since it's common denominator, I can write in ones of sine x times cosine x. That's the common denominator. And now, this is one of the trig identities that you should know. Cosine square plus sine square, which is 1. So that equals to 1 over sine x times cosine x. And as you can see, this is equal to this right here. Right? Okay, so review these problems. There's another part 2 online homework that you can you should do for more practice. And again, if you have any question, always email me, come to office hours. I'd be very happy to help you.